Okay, so continuing from the last one, um, where we left off was that we got the meteors to rotate. We improved our collisions. Okay, we're still able to shoot and all that. But now when they hit us, it looks like they're actually hitting us. So now we have to do is we need to add the score. So what we'll do is we'll go to the settings here, all the way at the top, and right beneath where we had the image folder, we'll just put score equals 0. Okay, and we're putting this all the way at the top because if we were to put the score inside of this while loop, okay, think about what would happen every time that we go around and complete a new cycle of this loop, right? If we put it inside here, the score would just be reset to 0 every 60 times every second, so you'll just never see your score. Okay, you could also put it up here if we wanted to. Like, we could have put score equals 0, which is outside of the loop. That's perfectly fine, but again, just for organizational um, reasons, we're going to leave it all the way at the top. Okay, so that way we know that if we want to change any of the settings for the game, we can just come straight here. All right, so let us come down here, see where we have our game functions. So we already have two functions in our main program, and what we'll do now is just add another one. So I'm going to use message to screen, okay, and then this will display messages to the screen. Now it's already written in the name of the function, as you should always do. Your function should always be representative of what it's going to do. But just if you want to add a comment, that's also good. All right, so some of the things we think about is what it is that we're going to be passing. Okay, the most obvious thing is we want to be passing the message that we have to display, and in addition to the message, we also need to pass the font size, okay, the color. Actually, I like writing the color first and then the font size. And then two things that you might not really also think about is the X and the Y position. Okay, because although we are displaying a score, we will be using this to display other things. Like if we had an intro screen, we're not going to just display the score, we're going to display a bunch of different lines, maybe instructions, but we can always refer to this function to help us display that. And they're going to be in different X and Y locations on the screen. So it's good to have that in there. All right, so before we do this, we need to have a one declaration. I'm going to put it up here, also in the settings. I'm going to call it font underscore name. Okay, and this is going to be pygame.font.match font. And I'm using match font so that the computer will go back and try to find a path to this exact font type, which is Comic Sans MS. Okay, this can be anything you want. If you don't want to have it, it's going to automatically default to sans serif if you enjoy that, or you can put like Times New Roman or Helvetica or whatever the other font it is that you want to use. I'm going to use Comic Sans MS. Okay, so we're going to declare that up here, and when we come down here now, okay, we'll have font is equal to, and we need to render this. So I have this here. Let me just make sure that I have this here. All right. So the first thing is we need to create a font object. Okay, and we're going to do that by saying font equals pygame dot font dot capital S system capital F font, and inside of here we need to put in the font name, which was font name. Okay, and then we also need to put in, I believe it is the size. Okay, now this size is going to always change. Our score is going to be small. Maybe our intro screen will have big font, and so that's why we had passed a font size up here, and so we're going to just put this. So the player is going to have to put this in, or rather we're going to have to be the ones to put this in later on in our program. Okay, then after that we can say message, or yeah, message is equal to, I don't want to use the same exact thing. We'll do text is equal to fonts.render. Okay, and we're going to render this, and I'm just going to come back over here, and it says that it's going to ask us, what do you want to render? Now I know it says text and I'm using the variable text, but this is saying, what do you want to render? We're going to render the message. Anti-alias is going to we're going to set this to be true, so it's going to nicely smooth out the edges for us. And then the color, that is another variable that we're going to have to pass later on. So we're going to have message, true, and color. Okay. All right. After that, we have a text. It's been fully rendered. It's been transformed into the appropriate font, the correct size, the correct color, everything. Now we need to create a rectangle around it. So we'll say text underscore rect is equal to text dot get rect, right? And what we're gonna do is we're gonna center it, okay? And what I mean by that is, do you see like up here, I have a pathway up here? This is centered perfectly. If we didn't center it and we just passed an X and a Y, it would start all the way over here on the left hand side, okay? Even if you were to do width divided by 2, the beginning of that rectangle would start in the middle. So it would always be off. It wouldn't look centered. So by doing this, we guarantee that we're going to be centering it like that. And then the last thing is we have to blit it. So screen.blit, and I'm using screen because screen is the name of what we described as our display, right? For our screen display that was up here. So if you named it something else, then you need to name it that. But for this reason, I'm using screen. All right. So screen.blit, and this is going to be what do you want to blit and where. So we want to blit the text, and where we'll just use the rectangle with the correct coordinates that we have passed. Okay, so this is the complete function just for displaying a message to the screen. We're going to go ahead and just copy this, okay, unless you remember all the parameters that we need. And I'm going to come down here, okay, and where you place it is important. Okay, the first thing that happens when drawing to a screen is that they put the background, then the sprites on top of that background, and then we're going to display the score. Okay, the message is going to just be as a string, score, colon, and then I have to use a plus sign because we have a variable named score that's going to hold a numeric number, and we need to convert that to a string. Okay, because we cannot concatenate a string with an integer. I'm sure everyone has had that error like 1,000 times. All right, I put that plus sign right in there. The color, I'm going to use white. The font size, I'm just going to choose 24. My X, which is going to be horizontal, I'm going to set that to width divided by 2. And then the height divided by 2. HT divided by 2. Okay, remember to always capitalize if that's how you declared it in the beginning. All right, so if we go ahead and run this, let's see what happens now. Okay, so well, that's not exactly at all what we wanted. Okay, so look what happened there. If we run the program, and I have a lot of things going on in the background, so that's probably why it's so slow. See the score is right in the center of the screen. That can be kind of annoying. So to change that, which one do we need to, change over here? Well, the width divided by 2 places it right in the center, but the height takes it from the top and pushes it straight down. So we're going to actually go back and just change this to become 10. Okay, that means that wherever it is on the top of the screen, we'll just move 10 pixels down. And so it's going to look like it's hovering on the top and not just like joined to the top of the screen. Okay, so running the program is going to give you something that looks like this. And now this is a lot better. However, though, if we shoot, okay, all the meteors are being, killed, but there's no score being added. And so we need to program that. Okay, now that's not too hard. What I'm going to do is I'm actually going to transfer over to something else. Let me see. All right, and this is how we're going to display to the screen. So the first thing is we have a bunch of different sized meteors. Okay, now what I do is I'm using a Mac right now, right? But I also have a Windows computer. If you go to where your image folder is and you click on the image, you can right click. Oh, my thing froze over here, so we're gonna just close that off. If you right click and go to get info, if you're on a Mac or if you're on a Windows, right click on the image and go down to properties, okay, and then go to detail if you're on a Windows, and you'll see the dimensions there. Okay, the dimensions is what we're going to look for. So the dimensions for the big meteor is 100 by 118 pixels, and then for a small meteor, it was only 30 by 30. So very big differences. Okay, but then you have to think about that a little bit more. Does it make more sense to give points or more points to a bigger asteroid or to a small asteroid? Right? Well, it may be like a little bit weird, but it does make sense to give more points for a smaller asteroid because it's harder to hit the smaller asteroid than it is the bigger one. Okay, so the way we're going to do that is, let's see if I can edit this. All right, here we go. Pen. Oh, not laser pointer. We'll use a pen. Okay, hold on. Let's see. How do you get out of this laser pointer? Hold on a second. All right. Well, I don't know how to get out of the laser pointer, but we'll try that again. All right. So, if the distance from here to here, right, is 100, and the distance from here to here is 30, okay? When I shoot this, I'm gonna use self.radius, which will find the radius of the image, and I'm going to give points according to that. Now, the bigger the meteor, the less points I'm going to give. So because it's 100, or rather it's actually 118, I forget which one is the width, but it looks like this might be the height, which is 118 by 100. I'm going to actually go and say maybe 150 is the points that I'm going to start off with, and I'm going to subtract self.radius. So for a big asteroid, right, if you hit that, you're going to be getting 150 minus 100, and you'll be getting 50 points for hitting a big asteroid. Okay, if you're hitting a small asteroid, okay, and I'm sure you could probably do the math in your head right now, you'll be getting 120 points. And that makes sense because it's harder to shoot the small asteroid as it's coming down, and some of them might be going faster than others. All right, so we're going to take this exact code here, and we're going to go to our score, and we're going to say, okay, the score is going to be plus equals all of this. And then we can just code that. One line. That's all we need. So coming back over here, is this the right one? Yes, it is. Okay, so we see where it says if the bullet hits a meteor. Okay, we did all this other stuff. The meteors, you know, they all die, they go away, we spawn a new one, and then what we'll do is we'll say score plus equals 150 minus self dot radius. Okay, now here's the thing is that if I use self.radius, that's not going to work. And let me just show you what happens. Because the self.radius is inside of the class. Okay, so nothing's going to happen. Oh, that was kind of a fail. I didn't even shoot anything. All right, watch. So you see how we have an error? It says name self is not defined. Okay, then I know the next thing you're probably thinking is, okay, so why don't we just use whatever the radius of the meteor is? Okay, and if we do that, we'll say meteor.radius, right? Maybe that might work. Okay, so again, hopefully this one's a little faster than yours. Okay, I shoot it and it says now meteor is not defined. Why not? Okay, well, let's think about this. Inside here, this returns a list. Okay, it returns a list of every single collision. Every collision is comprised of different images, each with different radiuses. All right, and then we use the for loop, and we have our temporary variable here, right, that loops through this list that contains all of the collisions. Now, when you use this group collide, all of these images here, right, and all the attributes for these images, it gets returned and it gets put into this list so that we can access the attributes in this list only for the meteors, not for the bullets. That's why we put the meteors first and not the bullets. We don't care about the bullets, but we care about the meteors. Okay, so what we're going to do is we're going to change this and we're going to put collision dot radius. Okay, so once again, all these attributes get returned in a list, all right, called bullet collision. All the attributes, such as, like, you know, all the vector attributes, the radius attributes, all that stuff. Then we're gonna use a temporary variable to loop through this list, okay, and as we're looping through, we can grab whatever attributes we want. In this case, we want the radius, so we're going to use collision dot radius. Now if we were to go ahead and run this, it should work perfectly fine. All right, so shooting it, and look at the score going up. Okay, so if I shoot a small one, well, here's a big one. If I shoot a small one, it went up by like 100 and something points. If I shoot small ones, it should go up by a little bit less. All right, and you can play around with the numbers and see how they are. I think maybe 150 might have been like way too much, because I'm at like 5,000 points right now. So I'm probably going to edit that. Maybe I might make it like 100 or something like that. But you can play around with it and see whatever it is that you like. And that's pretty much how you add a score.